For this RAM 1500 with the 3.6 Pentastar P0430 means the PCM may be seeing Bank 2 catalyst efficiency below the expected range. The driver may only notice the MIL, and the truck can often run normally. Broadly, this can involve the catalyst itself, exhaust leakage, an engine mechanical condition, or an aging or fouled oxygen sensor. The key here is not to condemn the converter too early. The PCM is comparing upstream and downstream oxygen sensor activity. So the diagnostic path is about proving the code is repeatable, making sure oxygen sensor faults are handled first, then checking the converter, exhaust, engine condition, and sensor history in order. The catalyst monitor watches both oxygen sensors and compares the downstream sensor activity against the upstream sensor activity over a calibrated period of time. A good catalyst stores oxygen and smooths out the downstream signal. Typically, if the catalyst is working properly, that downstream to upstream ratio is approximately 0.2/1. As the catalyst loses oxygen storage capacity, the downstream signal starts looking more like the upstream signal, moving toward 1/1. If the final test ratio is greater than 0.65, the PCM considers the catalyst failed for this monitor. The upstream O2 slow response diagnostic is evaluated before the catalyst decision to help avoid a false catalyst failure. Before getting into component checks, start with the basic system checks. The monitor runs when no other O2 sensor circuit faults are active. The best opportunity to get the catalyst efficiency monitor to run is engine temperature above 70 degrees C, 158 degrees F, engine speed between approximately 1,000 RPM and 3,000 RPM, and vehicle speed between 32 kph and 137 kph, 20 mph and 85 mph, under moderate engine load. First, use the scan tool to read DTCs in all ECUs and record them. Save the scan report and related recorded data, erase the DTCs, turn the ignition off for a minimum of 10.0 seconds, then turn the ignition back on. Use the captured conditions and the monitor gates to operate the vehicle, then read codes again. If P0430 returns, continue with the diagnostic path. If it does not return, treat it as an intermittent condition. Next, look back at the recorded codes. If there are upstream or downstream O2 sensor signal or heater codes present, diagnose those applicable O2 sensor issues first before continuing with this catalyst efficiency diagnosis. That matters because the catalyst decision depends on believable upstream and downstream O2 sensor behavior. If those O2 sensor signal and heater concerns are not present, move on to the converter inspection. Now visually inspect the catalytic converter inlet and outlet. Look for physical damage like dents or holes, leakage at the converter, signs that it is internally broken, or severe discoloration from overheating. If any of those problems are found, replace the catalytic converter, correct whatever condition may have caused the failure, and then verify the repair. If the converter inspection is clean, check the exhaust system for leaks. Pay close attention to leaks ahead of the converter, because even a very small leak can shift the upstream O2 sensor behavior and cause the catalyst monitor to fail. If a leak is found, repair or replace the leaking exhaust parts as needed, then verify the repair. If no leak is found, continue. After the exhaust checks, look for an engine mechanical issue. Check for excessive exhaust smoke from an internal engine problem, and verify the upstream O2 sensor is not fouled because of a mechanical engine failure. An engine that is consuming oil, coolant, or excessive fuel can foul the upstream sensor because that sensor is not protected by the catalyst. If an engine mechanical condition is present, repair that condition as needed and verify the repair. If it is not present, review the vehicle repair history. If the downstream O2 sensor was replaced recently and the upstream O2 sensor was not, the new downstream sensor paired with an aging upstream sensor may set this code. In that case, replace the front O2 sensor as necessary and verify the repair. If that history does not apply and no other possible cause remains, replace the catalytic converter and verify the repair. Keep the verification separate from the testing. After any repair, run the powertrain verification, reproduce the operating conditions as needed, and confirm P0430 stays gone. The takeaway is simple. Prove the code returns, clear out O2 sensor faults first, then work through converter condition, exhaust leakage, engine mechanical causes, sensor history, and only then the converter decision. For more diagnostic training, visit Diagnostics.com.